Hello, students. Today the topic is reaction with alkali second part. Already we have discussed reaction with alkali has two types of reaction, that is aldol condensation reaction and Cannizzaro reaction. In the previous class, we have discussed about the aldol condensation reaction. Today's class, we are going to discuss about Cannizzaro reactions. So already we have discussed what are the differences between these two reactions, aldol condensation reaction and Cannizzaro reaction, both reaction shown by carbonyl compound in the presence of alkali. But those carbonyl compound shows aldol condensation reaction with the presence of alpha hydrogen. So how they are differ from each other, the alpha hydrogen compound containing carbonyl gives aldol and the carbonyl compound having no alpha hydrogen present that shows Cannizzaro's reactions. Okay, already you know what is the meaning of alpha hydrogen. Okay, this is the carbonyl group, all of you know this is a functional group, and by functional group, the carbon which is directly attached, that is called alpha hydrogen, and sorry, alpha carbon, and the hydrogen attached by that alpha carbon are alpha hydrogen. So you can see over here, this carbon is alpha carbon, and the hydrogen which are directly attached to this alpha carbon are called alpha hydrogen. So you can see there is a three alpha hydrogen present. So the carbonyl compound having alpha hydrogen, that shows which reaction, that show aldol condensation reaction. Now you can see the another one more example. Okay, suppose this side is not any alpha hydrogen is present. Suppose hydrogen is there. Now this is a second example. You can see this is carbonyl group, and by adjacent carbon is called alpha hydrogen. So here is the two alpha hydrogen, sorry, alpha carbon. So sorry, at the adjacent carbons are alpha carbons. So here you can see there's a two alpha carbons and all hydrogen are alpha hydrogen. Okay. So both sides, the alpha hydrogens are present. So again, this will also responsible for aldol condensation reaction. Now moving toward the next example, this is again CO group. This side no alpha carbon, but this size one alpha carbon, and you know after the alpha carbon the next carbon is beta carbon. So the carbon which is directly attached to the function group is called alpha, and the next is beta, and the next is alpha, beta, gamma, delta, and so on. Okay, here you can say this carbon is alpha carbon. So these two hydrogens are alpha hydrogen. This is alpha hydrogen. This is alpha hydrogen. But the next carbon, which is beta carbon, so hydrogens are also beta hydrogen. And you know this aldol condensation reaction shown by only by alpha hydrogen, not by beta hydrogen. So only these two alpha hydrogen participate in the aldol condensation reaction. So this carbon and this alpha hydrogens. Okay. Now this is the next example. You can see over here also, this is CO carbonyl group. And by this carbonyl group, there is a no carbons attached in any one of the side. So there is a no carbon means there is a no alpha carbon and hence no alpha hydrogen. So this compound having no alpha hydrogen, so it will undergoes for which reaction? Cannizzaro reaction. Correct. So now in the previous class already we have discussed about the aldol condensation reaction. So now we are moving towards Cannizzaro reactions. So let's see the example of the Cannizzaro reaction and the concept about Cannizzaro reaction. Okay, so Cannizzaro reactions. This is the example of Cannizzaro reaction. Okay, uh, already just I have told this CO group and there is a no alpha carbon and no alpha hydrogen. So there is a no alpha hydrogen present. So it will undergoes for Cannizzaro reaction. Already we have discussed about what is the meaning of Cannizzaro reaction. So Cannizzaro reactions have two conditions. One is a no alpha hydrogen. First condition, there should be no there should be present of no alpha hydrogen, and second, the aldehyde group must present. So no alpha hydrogen and CHO group must present. Okay. And what are the reaction? Okay. So what are the Cannizzaro reaction? In Cannizzaro reaction, there is a, okay, you can see over here, there the CHO group is present and no alpha hydrogen. Okay. So what is this reaction? In Cannizzaro reaction, there is a use of 2 moles. This is inter-Cannizzaro reactions. So there is a use of 2 moles in which the 1 mole of CHO group oxidized into carboxylic group. So here we have taken sodium NaOH. So we can say sodium salt of carboxylic acid. If you take potassium, you can write potassium salt of carboxylic acid. Or if you write only alkali, so you can write carboxylate ion. So simply we can say out of 2 molecules, 1 molecule oxidized into carboxylic acid. We can say the salt of carboxylic acid, and the second molecule CHO get reduced into alcohol, means this CHO group reduced into CS2OH. So what I said, this CHO group oxidized into CONA, and this CHO second molecule CHO reduce into CS2OH, means one will oxidize into carboxylic and other mole will be reduced into alcohol. So what you're observing, the same 2 molecules, out of 2 molecules, one is getting oxidized, another getting is reduced. So this type of reaction is called disproportionation reaction. So already you know what is a, so this type of reaction is known as what? Disproportionation reaction. Okay. Means we can say Cannizzaro reaction is disproportionation reaction or self-redox reaction. Okay. So why it is called self-redox reaction? Because simultaneously get oxidized as well as reduced. Okay, I hope it is clear. So we can see, take another example even also. You can see the next example. This is benzaldehyde. In benzaldehyde, is again you can see is a no alpha hydrogen present. So what the product you get it? What just I told. Okay, we get what? So one molecule get oxidized into CHO get oxidized into CO, and potassium is there, so we can write COK, and another mole CHO get reduced into CS2OH. So simply you have seen one CHO get oxidized into CO and the second CHO get reduced into CS2OH. So what are the name of this compound? This is called, sorry, not sodium. This is called potassium benzoate, or we can say potassium salt of benzoic acid. And this is called benzyl alcohol. So we are getting acid and alcohol. Okay, what is the name of this compound? Sodium. It is called sodium formate, common name, or we can say sodium methanoate. And this one is, if you want to write combined form, that is called CS3OH, that is methanol. So methanol change into methanol and sodium methanoate. Okay, so better we can see more example. Okay, so this is inter-Cannizzaro reaction. So Cannizzaro reactions are 3 types, or we can say various type inter-Cannizzaro. Okay, between 2 molecules, that is called inter-Cannizzaro reaction. In the same molecule, that is called intra-Cannizzaro reaction. So this is another example. What is the common name of this is called glyoxal, or we can say ethane 1,2-diol. Okay. In this example, you can see though both CHO, two CHO groups are present, and there is a no alpha hydrogen present. So what happens in this case? The one molecule get oxidized and another CHO get reduced in the same molecule. So this is the reason it is called intra-Cannizzaro reaction. Okay. So what product we are getting? CO minus, and second get CS2OH. So we get this type of product. Okay. When it is further acidified, so we can get COH and CS2OH. If you want to write its IUPAC name, you can write it. What is IUPAC name? Yeah, we can say 2-hydroxy ethanoic acid. Okay. So this is intra-Cannizzaro reaction. We can see cross-Cannizzaro. Okay. What is the meaning of cross-Cannizzaro? So what I have discussed first is the Cannizzaro. We can say simple Cannizzaro reaction, or we can say inter-Cannizzaro reaction. Okay. So simply we'll say simple Cannizzaro reaction or Cannizzaro reaction. Second, we have discussed intra-Cannizzaro, means in the same molecule. Now, the third type of Cannizzaro reaction which we are going to discuss, that is cross-Cannizzaro. What is the meaning of cross Cannizzaro? Means two different molecules. Cannizzaro, same molecules, but cross Cannizzaro, we have to take two different type of molecules, or we are going to use two different molecules, and in both molecules, no alpha hydrogen must present. Okay. If any one of the molecule is containing alpha hydrogen, then it will undergo for aldol condensation, not Cannizzaro reaction. Okay, so now you see this is methanol having no alpha hydrogen. This is benzaldehyde having no alpha hydrogen. Okay, so if two different molecules both having no alpha hydrogen present, and in the presence of alkali, it will show they both will undergoes for Cannizzaro reaction. And this is cross Cannizzaro. Okay. In this cross Cannizzaro reaction, now the question is this: which molecule will oxidize and which molecule will reduced? Okay. So that molecule will oxidized, which is more reactive. Okay. And already we have discussed ki aliphatic aldehyde more reactive than aromatic aldehyde. And this is the reason the aliphatic aldehyde has more tendency to oxidize rather than aromatic aldehyde. So aliphatic aldehyde get oxidized, so aromatic aldehyde get reduced. So what product will get over here? COK. So this CHO get oxidized, and this aromatic aldehyde, that is CHO, get reduced. Okay, so we get these two products, benzyl alcohol. So there is a no any confusion, so we get this substance as a major product. Okay, now the second example, you can see both are benzaldehyde. Now in this case, which one will get oxidized? Definitely that molecule get oxidized, which one is again more reactive. And here in benzaldehyde, the nitro group is present, which shows minus I effect. And due to minus I effect, it is more reactive. So wherever the electron withdrawing group present or minus I effect is present, that will get oxidized, that CHO get oxidized, and another molecule get reduced. So again, what we are getting, this benzaldehyde, where is the no nitro group is present, that will reduce into alcohol, and another molecule where the nitro group is present, in that case the CHO get oxidized. Okay, so if you have understood this example, I hope you can do this question. Yes. Now in this question, you tell me which molecule will get oxidized. Again, you have to check this group. Now, this is what? Electron donating group. That means it shows plus I effect. And you know, as minus I effect increases, reactivity increases and tendency to get more oxidized. And in case of plus I effect, vice versa. So this one will be reduced, not easily oxidized. So in that respect, this one will be oxidized. So in this case, we get benzoic acid or sodium salt of benzoic acid. And the second molecule where the plus side effect is there, in that CHO group reduced into alcohol. Okay. I hope this concept is clear to all of you. Okay. So if you know about this concept, then you can identify. So you have just studied about both aldol condensation and Cannizzaro reactions. So if you understood about the concept of aldol and Cannizzaro, then you can easily identify which compound will undergo for aldol condensation reaction and which compound will undergo for Cannizzaro reaction. So now I have given two examples. These two examples, you have to just identify which compound will, among these two, which one will we show aldol and Cannizzaro or what. So now these two examples you can see. First, you have to check about the CO group and the alpha hydrogen. Now you can see there is a two carbon and both carbon having hydrogen. So these two carbons are alpha carbon having alpha hydrogen present. So obviously this example means this cyclohexanone undergoes for which reaction? Aldol condensation reaction, right? And then you can write the reaction. How you can write the reaction? Already we have discussed about the concept. Still, you can write this OH and double bond. The final product which we are getting is this. Okay. So I'm not showing this reaction. You just do by your own. Okay. Again, you will rewrite. Okay. Just I'm asking whether it will show which type of reaction. Now the second example, this is acetophenone. You tell me. Correct. Because again here alpha hydrogen present, so it will also undergoes for aldol condensation reaction. We can see few more examples. Now see the third example. Okay. CO group is there. Alkyl is there. It means it will show either aldol or Cannizzaro. Now we have to check alpha present or no alpha present. If alpha hydrogen present, then aldol. No alpha hydrogen, then Cannizzaro. So now this is a function group. The next carbon is alpha carbon. And this alpha carbon containing no alpha hydrogen, there is a methyl groups. So directly hydrogen is not attached. Means there is a no alpha hydrogen present in this example. And if there is a no alpha hydrogen present, it means it will show which reaction? Yes, Cannizzaro reaction. Okay, so this compound is responsible for Cannizzaro reaction, and same thing, the one molecule get oxidized into. So you can write the product even also. This CHO get oxidized into CO, and the second CHO get reduced into CS2OH. So you can write the product by your own. Now see the next example. This is benzophenone. First, you have to check whether alpha hydrogen present or not. Okay, here is no alpha hydrogen present. If no alpha hydrogen present, so what do you think? It will show what? Cannizzaro reaction? According to you? No. it will not show Cannizzaro as well as aldol condensation also. Aldol condensation is not possible because there is a no alpha hydrogen. And Cannizzaro is also not possible because just I told Cannizzaro reaction shown by those carbonyl compound where is no alpha hydrogen present and having CHO group, because the CHO group only can oxidize or reduced. But there is a no CHO group. Reduction is possible over here, but oxidation is not possible. As you know, ketone not easily oxidized into carboxylic group. Okay. The next example you can see, this is the cross reaction. Now this cross reaction, again we have to check both molecules. Any one of the molecule containing alpha hydrogen will show aldol, but if both molecule will not alpha hydrogen, then only Cannizzaro is possible, right? So this is the one, this is methanol. Already you know there's a no alpha hydrogen present. See the second molecule. This is CO group. This is alpha carbon where no alpha hydrogen, but there's an adjacent. This is alpha carbon. This is alpha carbon. This side no alpha hydrogen present, but this side alpha hydrogen present. So it will show cross aldol condensation reaction, right? Okay, correct. So it will undergoes for aldol condensation reaction, that is cross aldol condensation reaction. Okay. So I hope it is clear. Up to this Cannizzaro point is clear to all of you. No doubt. Okay. So now we'll discuss about the mechanism. Okay. So what is the mechanism of Cannizzaro reaction? You can see, so we can take one example, that is benzaldehyde. Okay. So let's see the mechanism how this benzaldehyde having no alpha hydrogen forms acid product as well as alcoholic product. So now what is the mechanism? Let's see. The one molecule of benzaldehyde in which the alkali, we can say that come from KOH, that is OH minus, and this alkali OH minus having negative charge, so act as nucleophile. So this is called nucleophilic addition reaction. Basically all reactions of Cannizzaro's are nucleophilic addition reaction. So this is nucleophile and hence it is nucleophilic addition reaction. This is the first step. This is the first step, and this first step is the fast step. Okay, so how this mechanism occur? This nucleophile, always nucleophile attack to the carbonyl, positive carbonyl carbon, and this pi bond shifted to this. Okay, so in this, what we get the product, just like a nucleophilic addition reaction, we get the product O negative, O minus, we can write H over here, and OH attached to this carbonyl carbon. So this is called hydroxy alkoxide. OH is there, so this is called hydroxy, and O negative is called alkoxide. Now this hydroxy alkoxide attack to the second molecule of benzaldehyde. You can see over here. That I can write over here, CHO. Okay. So now this is the second molecule in which how this attack, this O minus negative charge, again this lone pair goes to the oxygen, and this hydrogen shifted to this carbon, and this pi bond again shifted to oxygen. So there is a shifting of hydrogen, or we can say there is a shifting of H minus, which is called hydride. So this is the second step, and this second step is called hydride shift reaction. So first step is the nucleophilic addition, nucleophile attacking of nucleophile. So simply we can say first step is the nucleophile addition, or we can say attacking of nucleophile to the carbonyl carbon. And the second step, so this is the first step. In the second step, this is called hydride shift. There is a shifting of this hydride, which is called hydride shift. And we get the product that will be, what the product we get? You can see. So now this oxygen containing double bond and OH is there. So there is formation of acid, and this hydrogen shifted to this second molecule carbonyl carbon. So we get CO minus H and H. Again in the, this is slow step reaction, okay, fast step, slow step. Now in the third step, there is proton transfer. How proton get transfer? This proton, this H plus shifted to this O minus, and hence the product which one we get, that is CO minus, and this H plus, that is proton, shifted to the second molecule, and hence we get CH, H and OH, which is benzyl alcohol, that we can say CS2OH. So there is a formation of benzyl alcohol. And the another molecule get oxidized into carboxylate ion or sodium salt of, and this potassium, if suppose we are taking KOH, then potassium will attack to O minus. If we take NaOH, then we get ONA. So finally, okay, you can write even also. So final, this you are getting as a product COOK, or simply if you want to write in the detailed form, that means COOK, that O minus attached to this positive K plus, and the second molecule which already I have written, that is benzyl alcohol. So I hope it is clear to all of you. This mechanism is clear. Again, I am repeating that this mechanism occur in three steps. The first step, in which the nucleophile, that is OH minus, attack to the carbon, positively charged carbonyl carbon, and pi bond shifted to oxygen. Hence, we get this OH minus attached to this carbon, and pi bond shifted to oxygen, getting negatively charged. So this is called hydroxy alkoxide. In second step, and this first step is a fast step. In second step, this O minus negatively charged again shifted to oxygen, and this hydrogen shifted to the carbon, attached to the carbon, and pi bond transferred to oxygen. So this is called hydride shift reaction. Second step is the hydride shift reaction, which is slow step. And you know the slow step is the rate determining step. Further, so this we are getting what product? This O bond, double bond O and OH, and this H will be shifted to this carbon. So we are getting this product. And in the third step, this carboxylic acid H plus, that is called proton transfer, occur in the third step. So this H plus shifting to this O minus negatively charged, and we get this final product as an alcohol, and K plus attached to this O minus to form COOK. So this is a simple mechanism of the reaction. So I hope it is clear to all of you. So now you will practice it by taking another example, and you will understood everything. Concept will be clear. Okay, so thank you so much. So we'll discuss next topic in the next class.